Hello everybody, this is Mr. Bowman. Today we're going to be looking at the ALEKS topic, writing an equation that models exponential growth or decay. So for this one, we're just setting up our equation, and we don't have to do much with it beyond that. We're just kind of setting it up. So we have a sample of 350 milligrams of a radioactive substance. Since we started, a sample has decayed by 7.6% each year. Let t be the number of years since the start of the study. Let y be the mass of the sample in milligrams. Write an exponential function showing the relationship between y and t. Okay, so these ones do flip back and forth between growth and decay. The process doesn't change a whole lot. There's really only one small switch that you have to worry about. I'll mention that when we get there. So I know for any exponential function, it's going to be y equals a b raised to an exponent, in this case, t here. Because it's in terms of time. So we just have to figure out what a and b are. So a is easy. It's always your initial amount. And the only thing you really have to be careful here is to make sure the units match, but they usually do in ALEKS, so that's not a big deal. So it's just 350. And then this b value is the part that throws people off because there's a couple things you have to do. One, we want to figure out if it's growth or decay. So this is decay, so we're going to be subtracting this amount here. If it was growth, we'd be adding, which makes sense if it's in whatever it is we're looking at, in this case a substance. But if the amount was growing, you should be getting larger, so we're adding it to our normal rate. If it's decaying, it should be getting smaller, so hence the subtraction. But before I add or subtract, I need to switch this into a decimal. So I'm going to kind of come over here to my scratch area, and I want to take that 7.6%. To turn it into a decimal, I need to divide by 100. Okay, so this turns into 0.076. That's its decimal equivalent. And then I can now subtract. So to figure out what my rate actually is, I take a normal 1, which is 100%, and I'm going to subtract that 0.076. Okay, and this is where that one switch would change that I mentioned. If it was growth, you'd be 1 plus whatever the decimal equivalent was. Since it's decay, it's subtraction. Beyond that, it really makes absolutely no difference whether it's growth or decay. Everything else is the same. It's just that one addition or subtraction there. Anyway, so we have 1 minus 0.076. Be very careful with your zeros and decimal points here to make sure everything lines up. And you should get 0.924 from here. And that is the rate that goes right there. So initial amount, and then we do a little bit of calculation to figure out what goes in there. Well, we have our equation, so we're done.